say find the domain of something, you say to yourself in English what the problem is with this or what's needed for this to work. So for a square root, what must the inside be to make it stay real, to make it work? Has to be positive, right? So the inside must be positive. Now, math doesn't necessarily like to be defined by words. How else can I define positive in a more mathematical way? Actually, a better way to say than positive is non-negative. Because it can't be zero, right? Zero is not positive or negative. So the inside must be, what would be negative? How would it, what number would negative numbers be? Why are they negative? Because they're where?
More than 3.
Well, don't get too far ahead of it.
Less than 0.
Negatives are less than 0, so these must be the opposite. The inside must be greater than or equal to 0. Now think about that for a second, right? It can't be less than 0, so it must be bigger than or equal to 0. So that's how you say it in English. Here's the pseudo-math. What is the inside? 6 minus 2x. So 6 minus 2x must be greater or equal. If you solve this, that's the domain. If you can say it in English, you can write it in Mathish, and then solve it, and the domain just pops right out. That's kind of silly, right? So how do you solve this?
Minus 6.
Okay, I like it. So you guys are like, I don't like negatives with inequality. It's freaky. Let me make it positive. Divide by 2. Now this also freaks people out. It's always best to have the variable on this side so you can really see, because people would shade up here. That's not right. 3 is bigger than or equal to x, so x is less than or equal to 3. You got to turn it around. How we doing? All right, so that's the domain for f. I actually didn't. I just, if 3 is bigger than or equal to x, x must be small equal to 3. I just kind of reflected it, right? So the variable is on the correct side. Because now that points in the direction I would shade. That's how I see it points that way. That's the way I would shade. As long as the variable's on that side. So you guys do, what's the domain for g? Figure that out. Don't say it out loud. Do it. So I left the easy one for you guys. So the inside on G is x plus 1. How do you solve that? You just, so x must be greater or equal to negative 1. So the domain for f plus g must be those numbers that this and that define, right? So it's got to be true for both. So you could, if you wanted to, you could graph this. And how would that look? What symbol would be where?
Bracket of negative 1.
Good. And you shade up because it's pointing up. And right below that, I could put that one. What would that one look like? Bracket on the 3. And then down. So where is it true? Both of them. You can actually just do this. Joop. Joop. Right? If I would line it up, it would work better. But so from negative 1. So this goes all the way down, but these numbers don't work here, do they? So I can't use them. And these numbers don't work there. So the only numbers that work both are these numbers. So what's the domain for f plus g? It starts at negative 1, because that's where it starts being in both. And it ends at 3, because that's where it stops being in both. Okay, cool. So when I add or subtract or divide or whatever functions, the domains are kind of inherited, right? If this can only take certain numbers and this can only take certain other numbers, they both can only take the numbers that work in both. That's the idea. Okay. Any other questions before we get into new stuff? I'm sweating, so it's not that hot in here. It's just kind of muggy. All right, here we go. So today we're going to do 4445, get into chapter 5. I have a handout related to factoring. We're probably not going to make it to factoring today, but I just want to give that to you so you can look through it and go, oh yeah, I remember that. Hopefully. The thing we're going to talk about today has a couple of main different ways to do it. I'm going to show you one way, and I'm going to step back and see if anybody says something else, and then I'll show you that way if I hear it. If I don't, we're going to stick with the one way. Right? Okay. Here's the idea. What the hell? Well, let's start off with the realized absolute value basics. What is the absolute value of 4?
4.
Awesome. What's the absolute value of negative 4? Yay. What's the absolute value of 0? 0. Yay. So absolute values are one of the most single-minded functions ever. They just freaking make everything positive. It's already positive. What does it do to it? Nothing. If it's negative, it changes the sign. Right? Before I show you this then, how would I mathematically change this guy's sign? We would just take the sign away, right? How can I mathematically change that guy's sign? There's a couple different ways. I like it. I could multiply this by a negative. That would change the sign, right? So an absolute value of 3 would stay the same. The absolute value of negative 3, it would change its sign, right? So that's the funky thing about it. It only does something in certain situations. All right, so far so good, right? Real quick. Why does it always come out positive? What idea is absolute value based on?
Because the absolute value signifies its place on the number line.
Beautiful. Even more than that. Say again?
In relation to 0.
In relation to 0. So the distance from 0. So like 4 and negative 4 are both 4 away. I wouldn't say that Dennis is negative 4 feet from me just because I'm looking that way. He's 4 freaking feet. What's negative 4 feet mean? He's fallen into a dimensional vortex. He's negative 4 feet. He's inside. What the hell is that? I don't know. So that's the idea of absolute value. That's, of course, why absolute value is 0, 0, because it's 0 away from itself. So, just to blow your mind, what the hell is this?
Negative x?
No?
X.
No?
Any number?
0?
No? No?
1.
No. Why is there not a single answer to this?
We don't know what x is.
We don't know what x is. If it's positive, what will the absolute value do to it? Nothing. So if x is positive or 0, it's x. It will do nothing to it. I tried to build you up to this by what we just did here. If the input, if x itself is negative, what does it have to do to it? Change its sign. How do you change its sign? By doing the negative of it. And the minute I write that down, people go, no, it is negative. No. If x is negative, what's negative x? Positive, right? The whole idea here is it leaves it alone if it's already positive. It changes its sign if it's negative. It's freaky. Why? Because I don't know what the hell that is, and this does different things depending on what the hell it is. You guys with me? That's why when you bring variables in, things get more difficult. We're not purposely making them difficult. I've got to define this thing in general, and it's hard to do when it's dependent on what the hell you put in there. That's why it looks a little bit complicated. All right, so how are we doing so far? Has anybody ever seen this before? You guys remember this little setup here? This is called, what this really is called, names don't really matter, but this is called a piecewise function. It's defined in pieces. For the x is above 0, it's this. Below 0 is that. It's defined in pieces. Anyway, we don't need to know that. So what does that mean for me? What do you think about this here?
That's the square root.
What's got to be true about x squared?
Positive.
considering that x is real. We haven't gotten to complex numbers. It's got to be positive, so the absolute value will do nothing to it, right? Sweet. All right, that's one little side note. Here's something else. Let me show you this here, too. I like this kind of problem. All right, let me put this here. Let me put this over here. Give me some room. This is kind of taking this one step further. And normally it's more than the book will show you, but can somebody tell me, how do you write this if x is known to be less than 7? Now just think about that for a minute. If x is less than 7, what kind of number is this?
Negative.
And what does an absolute value do when we know the input's negative? It must change its sign, right?
Yeah.
And you just told me, we know this input is negative. So it will equal, it has to change this guy's sign. Now let's test this out. Let's test it out. Somebody give me a number that would follow my rules here. So for example, yeah, 1. What's the absolute value? 1 minus 7. Yeah, so 1 minus 7 is negative 6. What's the absolute value of that?
6.
What's 7 minus 1? 6. See? I don't know if you guys see what I'm saying. If I put a 1 in, what we claimed up here is the absolute value of this is equal to this. So if I put a 1 in, I'm claiming that the absolute value of 1 minus 7 is the same as 7 minus 1, which it is. Maybe. Now again, like I just said, that's a little further. I don't think the book does a problem like that, but it's really good to know that kind of problem. Once I start throwing things in, it kind of shifts where it changes from positive to negative, right? At 7, this is 0. So around 7, it'll be positive or negative. Okay, so let's get to the real meat. Let's get to what these problems are going to actually look like. So what do you think about, let me do it like this first. Let me just do it like no algebra even. What would I put in there? What goes in here? If I want the answer to be 11. 11. So 1, it could be 11. Or negative 11. So what I just did, of course, I kind of had the real way to write it just a second ago. The reason we have algebra is so I don't have to write all this shit. If I just say this, I've said all this shit here, right? Much better. So x kind of helps me stay away from what has to be put in here? Screw that crap. Let me just put x. That's the question. That is asking me what has to go in there to make this equal 11. That's what that really says. So let's see if you guys get the idea. The inside could be 11, or the inside could be negative 11. So what are we getting from this? Absolute value equations or inequalities will always have two cases. Why? Because you can get the same two numbers out if you put negative of the thing in there. You've always got two things you can put in to make it do something, right? So there's always going to be two cases for absolute value equations or inequalities. So what about this here? So the inside could be all right, so real quick word about this. This is not this. Right? An absolute value can't change a piece of a number. Right? An absolute value of negative 5. Well, negative 5 isn't negative 5 6 minus 11? Right? Isn't 6 minus 11? So you can't say, okay, absolute value of negative 5 is 6 plus 11 is 17. Yay! See, so be real careful. Absolute values don't make all negatives become plus. absolute values have a number, and they change it if it's negative inside, right? So this is not this, because I didn't change the whole number. I don't even know if this thing is negative or not. So be real careful about that by itself. I've got to write my two cases, just like we did up here. The inside is 11, or the inside is negative 11. Here, the inside is 3, or the inside is negative 3. Think about it. If this was equal to negative 3, you put a negative 3 in there. What's the absolute value of negative 3? 3. So you're saying if this was replaced with negative 3, this would be true, right? If it was replaced with 3, this would be true, right? So then you just solve these two dinky little equations. So just taking something that kind of looks ugly with absolute values and making it two little dinky equations, right? That's pretty nice. So I would get x is 4, or x is 1. I like it. Cool. How we doing? Yes, sir.
What's the real world application for absolute value?
Absolute values are useful for like restrictions on things. Absolute values are good. Well, I have a lot of mathematical uses for them, for when you want to force the answer to be positive no matter what. But in the real world, when the negative means like, I don't know if you guys realize this, but in physics, the negative velocity, if you're going backwards, you just say like going 10 miles an hour forward or negative 10 miles an hour this way. You got to define which way is positive, which way is negative. Sort of like on a number line. If all I want is the speed, it doesn't depend. I got to see the absolute value of that. So its usefulness is really more mathematical. It just says whatever you get, take the absolute value of it, because we don't care about the negative. That's one quick application, and that's a real quick way to say that to somebody. Instead of saying whatever you get, just say, make the negative go away if it's negative, and screw that. Just put an absolute value around it. That says the whole thing for you, right? A very nice mathematical thing that's useful for is, here's something that freaks people out. What's the square root of x squared? It's not x.
Plus minus x.
It's not that either. You got to be careful.
Plus minus x.
It's not that. Trust me. What's the square root of 3 squared? It is 3, not plus or minus 3. What's the square root of negative 3 squared? Don't say negative 3, you're wrong. What's negative 3 squared?
Negative 3.
9, and what's the square root of 9? So it always comes out positive. But you see why I can't say the answer is x? Because what's x here? Negative 3. Was the answer negative 3? It's 3, so it's always positive. How do I make it always positive? Throw freaking absolute values around it. So I appreciate that's an awesome question always is, what the hell do I need this shit for? Right? Sometimes it will be a little bit of a lame reason. This doesn't have exactly real world direct applications, but it's really useful for shorthand to tell somebody the answer here has always got to be positive. Right? Okay.
Question.
Yes.
Why you put negative on the left side of this minus 7, and right here you don't put negative before 2x?
That is the other way to do these problems. The other way to do these problems is to rewrite this as itself or negative itself. The reason I don't show that way first is because then people make mistakes with the negatives. They forget to distribute it. Do you see what I'm saying? I was sort of hoping that wouldn't come up, but because it is the other way to do it, but whenever I taught it that way, I always introduced more places for people to make a mistake. So stay with me now. If the absolute value of x is x or negative x, depending, right?
Yeah.
So you'd have two cases really. Say 1, it could be x. 2, it could be negative x. What's the absolute value of 2x minus 5? 1, it could be 2x minus 5. 2, it could be negative 2x minus 5. Do you see what I'm saying? So if this was the problem, then it'd say 1, it could be this, or 2, it could be that. But my way, all my way does is say, well, just bring the negative to this side. And to me, because what people kind of always did was they did this, and then you got the wrong answer because you forgot to bring the negative into this. So why do that to yourself? Unless you were taught that way. Was anybody taught to do it this way? It's okay if you were. I'm not going to hate you. Some of you guys are like, I don't know what the hell I was talking about. Is that? Okay. Either way, you would get the same. If I divide by -1, I still get exactly that second case I got over there, right?
Yeah.
And to me, it's just a lot quicker to do that. But I don't care whichever way makes more sense is the way you should do it. Let me show you a different way to look at one of these problems. Here, let me solve this problem, and then I'll show you a different way to look at it. Don't say it out loud. Just take a second and try to solve that. Anybody in here like a sound technician possibly, or have you ever seen the when you see the waveform come out and you change the gain and all that stuff, and at some point it either cuts the top of the peak off or does it ever invert the peak? So what I'm saying is y'all kind of at this point in your life realize that this represents possibly sound, right? A frequency of sound. If you turn the gain up, so you make it go really high, but then this is above some threshold, a lot of times it'll just invert it, which is related to absolute value we get, right? If I have a parabola, all right, I know I'm going off deep in here a little bit, but I want you guys to stay with me. If I have a parabola, and I want to take the absolute value of that, what's the only area of that parabola that would change? The area that is negative. So the absolute value of this parabola would just do this. It would flip that and make it positive, wouldn't it? So there's another kind of real world, not really application, but where you see the program trying not to just lose it. It wants to show it to you, but it's reached some threshold, so it just throws it down that way. So you can still see it. It doesn't just cut it off. But it's related to like an absolute value. It flips it to the part you can see. And you've seen that, right? Yeah. I've got verification of real world sighting. All right. So what do you guys do with here? What's the first case? I love it. So one case is leave everything alone. In the second case, this could be -2. Or you can put a negative this equals 2. I don't care. Either way, should give you the same answer if you do it correctly. Now I just solve really nice, easy equations. X is 6 or X is 2. Cool? What I'm about to show you, you never have to do. It's just a nice visual of what the hell that means. So what do we say absolute value is based on? The physical idea of distance, right? So what this is trying to say is what numbers are 2 away from 4, right? Isn't subtraction distance? But then the absolute value, make sure it comes out positive, right? So if I plot 4 down, here's 4, and I want to go 2 away from 4. Well, if I go up, where do I end up? 6. If I go down, where do I end up? 2. All right. So it's 2 away from 4. It could be up or down. That's why there's 2 cases, because you could go up or down. Okay, good. All right. Maybe. My students make fun of me because I say that a lot nowadays. I do this, and I say maybe. Okay. Let me give you one to try on your own here. Let's see who gets this. Don't do do the first step correctly, the whole thing goes to shit. So while you guys are doing that, anybody not get their test back yet? They came in after I gave it back. You guys can make corrections just like on quizzes. So who has the correct first step, just to kind of stop you if you're not doing the right first step? Good. So we get this idea a lot. You want to isolate where your variable is stuck, right? So I got to isolate that. Why does this look different than anything we've done yet? Because it's got an extra piece here. You don't just say this plus 2 equals 7 or this plus 2 equals negative 7, no. It's this that actually changes things. Now this is one problem where if you did it the other way, you wouldn't have to worry about moving that 2. But the idea of isolating where your variable is carried out through a lot of different equations. So I like reinforcing that idea as often as I can. So real quick little demonstration. How would you solve this equation? What do you think you would do? I know this is a little ahead of where we are, but you guys maybe can figure out what's the opposite of square rooting?
Square.
Square. So you get x equals 16. If I had this problem instead, if I had square root of x plus 3 equals 4, if I square both sides right now, that would so tremendously suck. For 2 reasons. I gotta FOIL this thing now. You can't just square each piece, can you? You gotta FOIL this shit. And you don't kill your radical. The whole point for squaring is to kill it. It would still be left alive in the middle term. Do you guys see that? The middle term is still a radical. What the hell did you do that for? No. So the funny thing when we get here is I sound like I'm teaching a government class. Isolate the radical. Right? Retire it. You isolate your radical elements and you kill them. So you have to subtract the 3. Get it by itself first. And now it's a nice, easy problem. No foiling needed because it's just one term. X is 1. How would we do it? So same thing here. Isolate where your variable is stuck. So move the 2 over first. And now it looks just like the ones you have absolute value equals something. Now you can apply the 2 cases, right? I like it. So be careful. If you did it the other way I was talking about, you could just replace this with itself or this with the negative of it and not have to move that because you're attacking only the absolute value then. But so you could do it that way if you wanted to. This way just makes it more universal. So what's one case? Leave it alone. I like it. Or I like it. And now I got 2 dinky little equations to solve. The biggest mistake that people make is they just treat it as if they weren't even there. They say, okay, that's 9, subtract 9, divide by 4, I'm done. It's like, wait, what? So the absolute values have to do something, and this is what they do. They make it turn into 2 cases. So then here I'll subtract 7, divide by 4, I'll end up with negative a half. And here I'll subtract 7, yeah, negative 3. Cool, I like it. Because that 4 right there is not as easy to do like this. That's why I made that a 1 here. Whenever you have multipliers, it makes that get a little funkier. But the same idea kind of holds for this. That's why you got 2. You go down or up. You got both situations there. Okay. Blah, 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 blah. God, they really overdo the graphing calculator in this section. Jeez.
Yeah, this book really likes graphic.
I know, and we will use the graphic calculator, but they just really overdo it in this one. What about this? Here, we haven't looked at this yet. What if I had absolute value of 2x plus 6 equals absolute value of 7 minus 3x. Now, I always get somebody who thinks maybe there's 4 cases now, right? And you're not quite right, because 2 of those cases are the same. So one case would be leave everything alone. Second case might be make this equal to the negative of that, make this equal to the negative of that. Those 2 cases are the same. And if you change both signs, make this negative, make that negative, don't the negatives cancel? So that's the same as the first freaking case. So you still have 2 cases, the same stupid 2 cases before. But now you can say like 2x plus 6 equals negative this. I'm sorry. One case is leave it alone, right? And then the other case would be 2x plus 6 equals negative this. So here you just can't escape requiring a distribution of a negative. I can't, because I don't just have a number on this side anymore. So now you solve both of those. So the nice thing is if there's 2 absolute value symbols, it's still the same steps. Exact same steps, exact 2 cases. So you can get 5x equals 1, so x is 1/5. Or here you get, so you get x equals 13. And you know, you can check your answers just like anything. You plug them into the original and see if it works, right? So if I plug in like a 13, I get 32, and I get negative 32. Well, the absolute values of those makes it 32 equals 32, check, right? Cool. Okay. So let me give you a couple of these to try, and I'll give you a chance to just shut up for a minute. Try these 2. While you guys are doing that, I'm going to pass out a handout that relates to chapter 5. Right, so you can just
I believe we skipped 4.3, or 4. Or no, not 4.2. We didn't finish the 2 sections of 4.
I'm just passing out a handout. That
Oh, I know, but we're going to do that.
So we're going to do that, yeah.
Okay.
Here's something a math person would, only a math person would be amazed about. There's exactly 6 people in each row. So that's neat.
And how many do you start with? 60 times?
There's always like at least 5 people out that day. So 742 people here now. I got 48 people officially right now, so there's about 6 people out today. So that's about on average. Number two, you will get one of them give you a freaky result. You should. So you go with the case, right? Either it equals 5 or it equals negative 5.
Shouldn't that 11 be negative 11?
No. Very first thing you have to do is isolate where your variable is. So you subtract that 6 over.
Okay.
So now it's a 5. So that 5 is a 5 or it's a negative 5.
Oh.
The 11 doesn't exist anymore. It's been changed to a 5 because I had to move that 6 over. Cool. If you remember, that's Calvin's moral objection to doing algebra. If you read my comics. That 11 has a right to be. I'm not going to subtract that 6 from that 4.
If you're going to do the weird one, right? What's the second part of the weird one?
No. Yes, I will. So what's one case here? Yeah, one case is leave it alone. And the other case, it really doesn't matter truly which side you make negative, but I just always make this side negative just to make it always the same. Right, so in one case it equals that, or it equals the opposite of that. So this side's nice, subtract the 7, add the x, get 2x equals 2, you get x is 1. Yay! And check, 1 plus 7 is 8, 9 minus 1 is 8, absolute values of course make them 8 still. Cool. But, what happens here? So you get 7 equals negative 9, so this case gives you nothing extra, no solution to this case. But what's the answer then to the whole thing? 1. So you have two cases. The answers from both cases are your answers. If one case leads you to nothing, then this is the answer. Right? So yeah, sometimes you will get that happening.
Since both of them is has absolute value sign, how come you don't make them both negative?
Well, and again, so if I look at this one specifically, if you think there's more than two cases, another possible case would be make this side negative, right? Right? But wouldn't that just be the same if I divide both sides, but it's the same thing as that?
And then like 2 negative.
Alright, so if I think another case would be make them both negative, the negatives would cancel, it's the same as that case. So that's what I went earlier. If you think there's 4 cases, 2 of the cases are the same. And one of them is the same as the first one. So you really just have 2 cases still. Good. Does everybody see that? Alright. Everybody's eyeing the clock already. Jeez. Okay. So I'm going to do, let's do one more idea here. Or when do you guys want to take a break? I don't know. You want to do one more section? Why don't we finish chapter 4 and then we'll take a break. How's that sound?
That is one more section, right?
Well, I mean like one more. Yeah, one more section. get strange. If you let them. I desperately want to make sure you understand the two possible situations. There's really only two situations here. You could have absolute value less than something. You could have absolute value greater than something. So for example, absolute value of x less than 2. What does that really mean?
Whatever the answer has to be, it has to be less than 2.
So here's the way I like to think about this. Let me see, what's a good way? If I had this, that would mean the distance from 0 is 2, right? So you go up 2 to 2 or down 2 to negative 2. And that's exactly what the two cases it would be, right? X equals 2 or x equals negative 2, right? Here I'm saying I want the distance to be less than 2. So I want to go up as much as 2, down as much as negative 2. Not even that far. I don't want to include those, right? Because it's not equal to. So this one I call the Sammich Situation. Or to be really dorky, say Sammich Sich. Right? Sammich because it's keeping it close. I don't want you to get further than 2 away from me. Stay close, right? Want your old house, flashlight's not really. Stay close, man. Don't get more than 2 feet away from me, please, dear God. So there's two things to realize here then. The visual is really easy, but then I want to relate it to the math because you're going to get uglier things in here. So here's the visual. I want to be at most 2 away, so I want to go, anything in here works, right? Because that would be certainly at most 2 away. That's pretty close, right? Up to 2, and of course down to negative 2. Notice what that means you should be able to write this as. If you look at this picture, what would it be written as inequality form? How would you write this in an inequality? Negative 2. Not interval notation.
Negative 2 is less than 2.
Less than x.
Oh.
Less than 2. Be real careful. If you say this, I understand what you mean, but you're writing something that's not very revealing. You're like, yes, negative 2 is less than 2. You have to kind of relate it to your variable, so you're saying x must be stuck in between these two, right? So the less than is a Sammich. It wants to keep it close. You can always rewrite it as this in between negative this and positive this. So let's stick on this idea for a minute before I get to the second one, the greater one. Let's try an uglier problem. Okay. So this is beautiful. This thing is silly how nice it is. This is a less than, right? So you think to yourself, it's a sandwich. Keep it close, right? The slices of bread and then the meat in the middle. That's the sandwich idea, right? So 3x plus 4 can go up to 7 and down to negative 7. There's your two cases. The two cases are kind of both there at once. Do you see it? There's always two cases, but in this case they're like bookends. So bookends. I said it right that time. I always say bookmarks. Bookends. Sandwiching the middle and the between. Right? Now you just solve this thing. How do you solve a double-sided inequality? What do you always do? If you subtract 4 here, you got to subtract it from both. Well, subtract it from all sides. So if you subtract 4 there, you better subtract 4 there. You better subtract 4 there. And if this was a 4, this side doesn't disappear. It becomes 0. The side can't just suddenly go away. 0 is a number. Use him, poor little dude. But I didn't get that here. What did I get? I get 11 less than equal to 3x less than equal to 3. And last step, divide everything by 3. I get a lot of people that like to do this. They do that problem, and then they do that problem. If you really like doing it that way, great. It's just a little extra work you don't really need to do. But and now I get this ugly piece here, nice piece over there. How would you graph that? What is negative 11/3 close to? It's almost what?
Almost 12.
No.
I'm sorry.
Yeah, negative
4.
Yeah, it would negative 12/3 would be negative 4. Negative 11/3 is then a little bit below that, right? And what symbol would you put on it?
The bracket.
I like it. And then up to 1, bam. So interval notation, oh, I'm probably kidding this on video. Oh well. Hey, you can't see this problem. What would it look like, interval notation? Negative 1/3, comma, 1, bracket. I mean, that's nice, right? So a less than with an absolute value is a sandwich. Keep it close. The distance less than something. Stay close to me, right? So here, before I get too far, try this problem yourself.
So wait, question,
Oh,
the
yep.
answer, if you want us to put like the brackets with the 11.
I would say the same as any inequality. I would say solve it, graph it, interval notation it.
Okay.
Yeah. Just to make a verb out of interval notation. So you guys try this one here.
Your phone.
Oh, is it?
Oh no, it might be still. Yeah, it's still.
Is it right?
Still going.
Let's see what time we got
Hour,
here.
right?
Oh yeah, I got 14 minutes. Plus the batteries. About to die, poor little dude. Alright. Let's move out. Sure. Alright, so do that problem there. Oh yeah, that'll be quick. That's right. Put a little present in here for you on this one. Let's see if you catch it. Yeah, you really didn't have to give me an other check. Just make sure we all start off on the right step. How do you rewrite this on the right off the bat?
Less than 2 minus 5.
So see, there's the case that stays the same, right? And real quick, just to kind of show you guys, the other case, like I was saying earlier, there's the case that stays the same. The other case, if you really want to get into it, would kind of be the negative of this, right? And if I divide both sides by -1, do you see how that becomes a -9 and the sign flipped? So it doesn't say, if you read it this way, what does it say? -9 is less than this, which is less than 9. That's why I can put it all together into a sandwich. Okay, right. So now I just got to solve it, get some ugly fractions, but you don't care. The one thing you got to be careful about is your variable has a negative coefficient, right? So at some point you're going to have to divide by negative.
So how,
This one.
on that part right there, how you did it with 2, so when you separate it into 2 separate problems, you make it, since you're making it into a negative now, you have to change the sign? Is that why you changed it?
Exactly. Cool.
Oh, I see, so the other side will be negative. Okay.
Yeah, with the equals it was kind of hidden, because if you flip an equal sign, it's still an equal sign. But here it shows up that if you make it negative, you actually have to flip the sign too.
Okay.
Yeah. But it's just easier to think about it like slam together like this. So the last step here, divide by -5, so what has to happen?
What's the sign?
Yeah, so you get 11/5 greater than x greater than -7/5. This kind of grates on me. I look at that and it kind of is like nails on chalkboard. I don't know if any of you guys see why, because these inequalities kind of point in the wrong kind of way. I always want smallest to biggest. So just flip the whole thing around. And that makes a little more sense when you go to graph it. You don't put a bigger one less than a smaller one than in your graph, right? You guys kind of see what I'm saying?
And you can do that if it, even if it's the other, if it's a greater than problem?
Yeah. In fact, the greater than problem, we're going to have to do it in 2 pieces.
Oh, you can't do it like that?
If a less than problem is stay close to me, what's a greater than problem?
Get away.
Stay the hell away from me, right? I call it a restraining order problem. Because it's exactly what it is. You can't only come within 100 feet. So you can, on this side, you can only come, you have to stay away by 100 feet. So more than 100 feet that way, or less than negative 100 feet that way, sort of thing, right? So it would be 2 separate sets. It'd be that set or that set. 2 separate things, right? So with that says, and I segue into that kind of problem, yeah.
Where you have the positive 11 over 5, why did you switch the greater?
I didn't. If 11 fifths is greater than x, x must be less than 11 fifths. So I mirror image it when I turn it around, right? If I leave these as they are, I've actually changed the problem. This way, I haven't changed the problem. I'm just looking at it the other way, yeah.
Isn't that still an and if you graph it though?
Yeah, this one is still an and. Yeah.
Because we switched it.
It'd be an intersection, yeah. These really say the same thing, it's just that this makes a little more visual sense.
No, but you were talking about staying away, and I'm thinking that would be or.
That would be or, yes. That's going to be an or problem.
So even though it's basically the same, you're just looking at it differently if we put that on the past. So I was like, if we don't switch it, but we know what it is, we can do that.
That would be fine, especially if you do it correctly, if you graph it correctly. So here to graph this, just to get to the point here, it would be this here, right? You don't want to include the ends. And then the interval would be this, comma, this, right? Interval addition comes right off the graph if you use those symbols.
And if you come out with something that doesn't make sense, like if
if you come up with 3 less than x less than negative 2.
that means
And you go, well, 3 isn't less than negative 2. You made a negative mistake maybe somewhere, like a negative sign didn't cancel somewhere or something. Yeah.
For tests and quizzes, can we graph that simply? I mean, or do you want a 0 in there? You know what I mean?
This is actually fine. I mean, truly, I want you to be able to find 11 fifths on a number line, but I mean, this is fine. You don't have to, because I always get somebody, if it's negative 2 up to 14, I get somebody that does, you know, you don't have to do that. It's okay. All right. So tell you what, let's compromise. I'll do this other idea, and then we'll take a break. And then we'll finish out chapter 4, and we'll probably do maybe the first 2 sections of 5. We'll see. Because 5 should be major review. 5 is like foiling and polynomial stuff, right?
So we'll have a test on 4 and 5?
I can't remember what I put on the homework sheet. I can't remember.
It's the homework sheet.
Yeah, whatever the next test is going to include the last 2 parts of 4 now. So it all depends. Again, I'll modify it if we get close to the test date and we're not as far as I thought. I'll modify it again, just like I did last time. So case 2, what about greater than? So we start here. This says the distance from 0. And it's because there's like a minus 0 in there, right? That's why I keep saying that. So the distance from 0 is got to be at least 7. So that's why it leads visually to at least 7. I lost count, but hopefully it's 7. At least 7 away would be 7 up or 7 down. And I don't want you to be closer to me, so you obviously must be further than that, right? So it would be 7 up, and then 7. Is that commercial too old, really? The Uncola, you remember that? The Uncola. Yes, a few of you guys remember. The rest of you guys like, alright, old dude. Do you guys see now how this is very different, obviously, from the other one? The other one would have taken the inside. This takes what the other one left out. You guys see that? Here would be the sandwich, and here this says, no, you got to be at least 7 feet away from me at all times. Right? Which is still pretty damn close. You can shoot me from that range. Screw it.
My personal bubble.
Yeah. So how would you write this in interval notation?
Minus infinity.
Good. Minus infinity up to minus 7 inclusive, or 7 to infinity. So how would you be able to write this? You cannot write this on a single line. Do you guys see why? You have two separate defined answers here. One answer would be x less than or equal to negative 7. And the other one would be x greater than or equal to 7. So less than is always kind of nice algebraically because it keeps it close. You can write it as a sandwich. You can solve it nicely. This one, stay away from me, it's got two separate regions, up there, down there. So I've got to write it as two separate equations here, right? So this can be written as this or this. There's your two cases. So what about a more complicated problem? 2x plus 11. You can do it. There you go, Jeff. Yeah, it's greater than 7. Sure. So you can automatically write your two cases. You say to yourself, okay, it's a greater than problem. Stay away from me. So even if you just do this, you're like, oh, it's got two separate, either up there, down there, two separate things. So one case is the same as always. One case is leave it alone. The other cases change the signs, right? Or what? 2x plus 11.
Less than negative.
I like it. Less than negative 7. So this has to either start at 7 and go up, or it's got to start at negative 7 and go down. Stay away from me, right?
So can we write it like the negative 7 is less
Now be
than
careful.
2? Okay.
If you did, now watch. If you try to write this in a line, it would be like 7 less than this, less than negative 7. Now why does that make no sense? Because if 7 is less than something which is less than negative 7, do you guys see what I'm saying? It's going the wrong way. Visually, it should make sense that you cannot write it as a sandwich. I said I want you to stay away from me, not stay close to me, right? So I'm not trying to sandwich myself in between the places where you can be. I want you up there, down there. It's got to be separate.
Okay.
Cool. So less than is nice because you can write it as a sandwich, which algebraically makes it quick. Because I want you to stay close to me. Here, I want you to stay the hell away from me. Right? See? I like it. So these are always ands. Those are always ors because they have two separate places. Here they want the overlap between that and that. The intersection between those two. I like it. So now I just got to solve both of those. What do you get here? That or c minus 11 x less than negative 9. So then to graph it would be pretty simple. Here's your negative 9. Blah. Here's your negative 2. Just make sure you get them on the right side of each other, right? So greater than negative 2, so what would that look like? Parenthesis and going up that way. And less than negative 9, so parenthesis going down that way. And then you can write your interval notation off of that. That's the way it says. Normally we can go from this to a graph pretty easy. And once you get the graph set up, the interval notation is pretty damn easy. This would go from negative infinity up to negative 9, or negative 2 up to infinity. Please don't do this. What did I just do? I found infinity. That's like nirvana. There it is, and then I'm gone. Where'd Jeff go? Like powder, I'm now lightning. Have you guys ever seen that? So you don't put that, and also don't do this. That's way too specific. What represents x in my